Alright, so in today's video we're going to be covering scientific notation. What is scientific notation? Well, it's basically a form of expressing really big or really small numbers in a more convenient way. It is used in science, or it's called scientific notation because it's used in science. Because in science we often have to work with very big or very small numbers. A number written in scientific notation has the form of a times 10 to the power of b, where a is a number between 1 and 10, and b is any full round number. For example, 1, 2, 3, 4, but also -1, -2, -3, or even 0. Okay, so any number, any full round number could be b. But a has to be a number between 1 and 10. With this in mind, let's see if we can express a number or some numbers in scientific notation. We're basically going to be covering in this video some examples of turning numbers into scientific notations, and vice versa. So for example, a very small measurement could be 0.00000000035 meters. Because this is a very small number, we might want to apply scientific notation to it. So what do we do to turn this number into scientific notation? Well, first, we have to look for what is different from 0 in the number. So this is different from 0, the rest is 0. And we have to write down that number, but in a way that number is between 1 and 10. So we're going to find a is basically the part of the number which is not non-zero, so in this case 35. But we're going to write 35 as a number between 1 and 10. How are we going to write this number? Basically 3.5, we're going to move the comma, so it is a number between 1 and 10. We will see different numbers now, so this is a bit different for other numbers. Don't rush too much. We're just going to cover some examples now. Okay, so we found a, and now we have to find b. How do we find b? Well, b is basically the number of steps we have to move the comma in order to get it to where it stands here, between the 3 and the 5. So how many times do we have to move the comma for this to work? Well, it has to come from here 1, 2, 3, 4, 5, 6, 7, 8, and 9 times. In order to move the comma from where it was to where it's going to be, I had to move the comma 9 times. 9 times to the right. Okay, so if I had to move the comma 9 times to the right, then number b is going to be -9. If we move the comma to the right, then the exponent, the b, is going to be negative. If we move the comma to the left, then the exponent is going to be positive. And that's basically all we need to know. Once we've identified a and b, we can write down the number in scientific notation, 3.5 times 10 to the power of -9. Let's see this with another example. See if we got it right. For example, we can have the number 745 billions, or billion kilograms, right? This could be, for example, the mass of a black hole, a very, very massive thing in the universe. Very, very massive thing in the universe. 745 billion kilograms. So how do we write this number in scientific notation? Well, we look for the number which is different from 0, which is 745, and we write it as a number between 1 and 10, which would be 7.45. This is a. And now we have to see how many times did I have to move the comma in order to get it to where it's going to be now. So between the 7 and the 4. Comma was here, and I have to move it 1, 2, 3, 6, 9, 10 and 11 times. Well, it's turned into a straight line, sorry. But I hope we were able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 times, right? So B is going to be 11. And it's going to be 11 because it's moving 11 times to the left. And we say if we're moving to the left, then it's going to be positive. So it's plus 11. And this number in scientific notation is going to be written as 7.45 times 10 to the power of 11 kilograms. This is the same number, the same quantity as before. It's only written in scientific notation. So we're basically making use of the powers of 10 to compress a big number. Because as you probably know, powers of 10 only add or eliminate zeros. So if we've got a number written in scientific notation, we can also turn it into a standard notation. If we have 2 times 10 to the power of 3, we can easily turn this number into a standard notation. We only need to move the comma as many times as the exponent b says. So I have to move the comma 3 times. If I have 2 comma nothing, because this is followed by nothing, I just have to move the comma 3 times. 1, 2, and 3. It's positive, so I move the comma to the right. Note that I'm doing the exact opposite thing here as I was doing before. If I move the comma to the right, it's because the exponent is positive. But the other way around, if I had to move the comma to the left, then the exponent is positive. Right, so I'm doing the other way around. So 2 times 10 to the power of 3 would be 2,000, because I have to move the comma 3 times, from 2 to 2,000. I add zeros in those empty shelves. If I have to turn the number 6.3 times 10 to the power of minus 4 into the standard notation, then I had to move the comma 4 times, in this case to the left because it's negative. So if I move this comma to the left 4 times, 1, 2, 3, and 4 times, then the comma is going to be here, and I will have 0.00063. 0.00063 is 6.3 times 10 to the power of 4 in scientific notation. Okay, so we've basically done some examples. You have many more on, we're going to be working in class. And scientific notation is going to be extremely important in this course in order to understand very big and very small numbers in science. Small numbers such as atom size, big numbers such as the mass of a black hole. Okay, I hope you liked the video. I hope it was useful for you, and see you in the next one. We're getting to the end of Unit 1. We will soon get to the end of Unit 1. See you.